NCS is a very interesting molecule. It's actually quasi-linear. When we got the microwave spectrum of it, it had a lot of vibrational structure, and it was made by, as you see, by pyrolysis of sulfur dicyanide. It rearranged. That was discovered by Mike King in the original experiment. Now, when we looked at the microspectrum, it's very interesting. It looks very complicated, but you don't have to worry, because I'm going to tell you roughly what happens. When you analyze it, you find that the K0 is in between the K equal to 1 on either side. That's a characteristic of an asymmetric top. So if it's a bent molecule, an asymmetric top, the K equal to 1 lines are wide apart, and K equals 0, 2 and 3 are usually near the middle. And you can see here that the 0 is roughly midway between the K equal to 1s. Now, as you go up in the vibrational level, you find that things are slightly different. The 0 is starting to move across, okay? That's the first vibrational level, V equal to 1. And then if you go to the second one, the 0 has moved outside, and that gets to be characteristic of a linear molecule where the 0 and the K equal to 1 are split by L doubling, okay? And if you go to K to 3, which is shown here, it's quite clear that the 0 is far outside the two K equal to 1 lines. So what is happening is that as the molecule bends more and more rapidly and vibrating, it averages out to something more like a linear molecule, and the microspectrum looks more like a linear molecule than an asymmetric top one. And that really was very nice, and here I show you the whole range of those on one particular diagram. Now, what was interesting is that Brenda and Manfred Wienerwisser are now at Ohio State, together with Frank DeLucia and Benka and Medvedev, have looked again at this, and Steve Ross, and there's a lot of people, Jacek Koppert. And what they say really rather nicely is that it was established by a brilliant analysis by my group. In fact, it was mainly the work of one particular guy at the analysis, Barry Landsberg, who did a beautiful analysis and worked out what was going on. Now this is not for you to look at other than to see how complex the spectrum turned out to be, but by analysis of all this, they've looked at these lines again, and it's very interesting. What they found is that as it bends, they've gone through the monodromy point, the top of this sort of sombrero Mexican hat potential, and they've got some beautiful structural data, more accurate than ours, and they have shown, as you see here, when they get to V equals 6, the pattern becomes that of a linear molecule again. It's very beautiful, and it's a beautiful molecule, and it's so nice to see that it still is living on and giving people some nice work to do.